Welcome. My name is Andrea Michael, Product Manager at Microsoft. This session covers strategies to optimize Azure networking costs through smart architecture, operations, and tools. Azure offers secure global networking solutions with a range of offerings. Azure's philosophy is to minimize the cost of moving data by providing customers with the tools to construct and maintain an efficient network architecture. Our goal is to help you identify where costs accumulate, how to design for both efficiency and effectiveness, and how to leverage Azure's built-in tools to keep spend predictable and manageable. Azure's infrastructure encompasses compute, storage, and networking to deliver scalable solutions. Cost optimization relies on understanding their interactions, especially in network design. How you architect connectivity, such as minimizing cross-region traffic and right-sizing gateways, helps control cloud spend. Even well-optimized compute and storage cannot fully capitalize on cost savings if data is constantly moving across expensive network paths. Designing for locality, optimizing routing, and using Azure's built-in tools to monitor and manage traffic makes network expenses predictable and operations more efficient. This video covers practical ways to reduce Azure networking costs through smart architecture and built-in features. We'll outline cost factors and present strategies and tools for building scalable, efficient networks without overspending. Networking costs can be subtle and yet significant at scale. As cloud architectures grow, costs related to data movement can accumulate, especially across regions or out to the internet. Poorly optimized networking can reduce your return on investment, or ROI, especially as workloads scale. Even with efficient compute and storage, ignoring network traffic patterns may lead to missed cost savings. For example, Azure charges for outbound data transfers, so scaling up users and traffic can result in unexpected fees. As your user base and traffic scale up, those outbound data transfers, or inefficient network routes, can quietly increase costs. If we ignore networking inefficiencies, you may be losing money in ways that aren't immediately obvious. Cost optimization goes beyond just cutting expenses. It's about enabling innovation and supporting growth. Saving on Azure network overhead allows reinvestment in new services and scaling to more users. By removing inefficiencies and following Microsoft's guidance, you free up budget for higher value projects. Efficient networking can fund experiments or upgrades without additional spending, and a streamlined architecture improves scalability by minimizing per-user costs. So in short, optimizing costs means doing more with Azure, innovating, scaling, and delivering value while maintaining your budget. Fortunately, Azure gives us built-in advantages to optimize networking costs with transparent pricing, pricing calculators, and cost management. Its global backbone network enables lower-cost, high-performance solutions by keeping traffic internal when possible, such as with service endpoints or private link, avoiding egress fees, and enhancing security. Virtual network peering further reduces costs compared to external data transfers. Tools like Azure Traffic Manager optimize routing for both performance and cost. Azure's networking services lineup includes many options to optimize cost, so you can choose the right tool for the job. Before diving into optimization, it's important to understand what drives networking costs in Azure. Azure's pricing model for networking has two main components: infrastructure charges at hourly rates for certain services, and bandwidth usage charges primarily for data egress. In simple terms, you pay for what networking services you provision and how much data you move. Let's walk through the key networking cost drivers one by one. Data transferred out of Azure data centers or bandwidth incurs costs for outbound or egress data and cross-region transfers. The rule of thumb in Azure and most clouds is that inbound data is free and outbound data is charged. This means you can upload data into Azure at no cost, but whenever data leaves Azure, you incur egress fees. When you're dealing with a higher scale of data leaving Azure, this cost can add up quickly. Azure does give you a bit of a buffer for egress data with your first 100 gigabytes per month being free and tiered pricing with volume discounts, but it's still easy to quietly rack up costs via egress if you're not careful. When connecting virtual network peerings incur charges depending on whether the peering is within the same region or is global and across zones. The Azure Virtual Network Service itself is free to use. You can create virtual networks and subnets at no charge at all, but connecting multiple virtual networks via peering does incur a cost. The peering charge applies in both directions, and global peerings have a higher cost than regional peerings. When you deal with private access for your resources, private link and private endpoints are frequently used to secure Azure services. Azure Private Endpoint attaches a private IP from your virtual network to an Azure PaaS service, keeping traffic on Microsoft's backbone. While this enhances security, each private endpoint incurs hourly and data processing charges. Plan and consolidate endpoints to avoid sprawl, keeping your security value high and the added cost balanced. Hybrid connectivity, or linking Azure to on-premises or cross-cloud environments, is another area with its own cost structure. ExpressRoute provides a private connection with a fixed monthly charge for a circuit speed and outbound data charges, making it cost-effective for high data volumes. Be sure to select the right circuit size, as unused circuits still incur fees. VPN gateways use IPsec tunnels over the internet and charge hourly by SKU, plus possible data transfer fees. Always match service choices to actual needs and avoid paying for unused capacity. On the security front, Azure Firewall provides network-level filtering, application rules, threat intelligence, and more with hourly and per gigabyte charges based on SKU. Plan accordingly for both firewall-based costs and workload traffic. Network security groups, or NSGs, provide free Layer 4 access controls on subnets and NICs suitable for basic filtering. NSGs can complement firewalls for enhanced security without sacrificing key protections or design efficiency. Azure provides a suite of services for load balancing and traffic distribution, each with distinct pricing, some fixed, some variable. Standard Load Balancer, or SLB, at Layer 4 charges by number of rules and data processed. Inbound NAT rules, like port forwarding rules, don't count towards those rule charges. There's also no charge when the load balancer has 0 rules, so an unused load balancer won't incur an hourly cost. Typical costs for SLB are low unless bandwidth is very high. Consolidating SLBs can further reduce expenses. Moving up the stack, Azure Application Gateway at Layer 7 acts as a load balancer and web application firewall, or WAF, service, with V1 charging per instance hour per gigabyte and V2 offering auto-scaling based on capacity units and fixed costs, optimizing spending for varying traffic. Another service to consider is Azure Front Door, AFD, a Layer 7 service that distributes global traffic. AFD charges a base monthly fee per profile and additional rates per request and gigabyte delivered. Cached content can lower egress costs, though AFD's rates still apply. Premium SKUs have higher fees for advanced features. To sum up this category, load balancers and traffic distribution services carry modest costs that scale with usage. By thoughtfully selecting the combination of appropriate services that deliver clear value to your network architecture, you can avoid redundant transfers and improve cost efficiency rather than simply cutting corners. Across all of these cost drivers, it's essential to identify which workloads generate the most traffic, where that traffic flows, and why. This understanding of your network architecture lets you target optimizations where they'll have the greatest impact on performance, efficiency, and cost. Now that we've gone through the various cost drivers for networking, let's dive into how you can optimize your network architecture to reduce data transfer and egress costs while selecting the best Azure networking services and features for your needs. Let's talk about practical architecture strategies to minimize Azure networking costs, especially those related to data egress and transfer. Keep traffic local where possible. Co-locating interdependent resources in the same region is one of the most effective ways to reduce cross-region charges. When your compute, storage, and networking resources are deployed together, you avoid unnecessary data transfer fees and latency. Strategically place your resources. Leverage Azure Traffic Manager or Azure Front Door to route users to the nearest region. This helps avoid hairpin traffic, where data unnecessarily travels between distant regions, driving up both costs and latency. Use caching for content delivery. Deploy Azure Front Door to serve cached content from edge nodes. This compresses data at the application layer and reduces origin egress, meaning less data needs to travel from your core resources to the edge, saving on outbound bandwidth. Avoid unnecessary internet egress. Whenever possible, use private link, service endpoints, or ExpressRoute for Azure to Azure and hybrid traffic. These options keep your data transfers private and more cost-effective compared to public internet routes. Consolidate resources where it makes sense. Implement hub and spoke or vWAN architectures to reduce redundant gateways and firewalls. When done correctly, consolidation helps you avoid duplicate charges and simplifies management. Utilize new Azure SKUs that are available for networking services. Take advantage of new VPN and NAT gateway SKUs, which are designed to ensure reliability and help avoid business disruption costs. These newer options may better fit your network architecture and be more cost-effective for scalable, secure connectivity. These strategies can reduce costs without sacrificing performance or reliability. Now, let's focus on how to minimize egress and cross-region traffic in Azure, which is a key strategy for controlling networking costs. Co-locate compute and storage resources. By placing your compute and storage in the same region, you can significantly reduce cross-region traffic. This not only lowers your data transfer costs, but also improves application performance by reducing latency. Use Azure's regional presence to your advantage. By keeping your data close to your users and applications, you can further reduce both latency and egress charges. Always consider the geographic distribution of your workloads and users when architecting your solutions. Cache and compress data at the VM or application layer. Implementing caching strategies and compressing data before it leaves your VMs or applications helps reduce outbound traffic. This optimization ensures you're using bandwidth efficiently and only paying for the data that truly needs to be transferred. Designing for cost-efficient data movement in Azure means thinking carefully about where your resources are placed, how your data flows, and how you can optimize those flows with caching and compression. These steps help you keep networking costs predictable and as low as possible, while maintaining high performance for your users and applications. Let's talk about how to optimize routing costs in Azure with a special focus on ExpressRoute. Azure networking costs can vary significantly depending on whether you're using internet egress, cross-region, or ExpressRoute. It's important to know which path your data is taking, as each option comes with its own pricing model. For steady, high-volume data flows, ExpressRoute often provides the most predictable and cost-effective solution. ExpressRoute is ideal for workloads that require consistent, high-bandwidth connectivity. You can choose between metered or unlimited plans based on your actual utilization. By right-sizing your ExpressRoute circuits, you avoid paying for unused capacity and keep costs under control. Avoid surprise routing costs and be aware of hairpinning, again where data unnecessarily takes a circuitous route, which can lead to unexpected charges and additional latency. Always review your network architecture to ensure data is routed efficiently and not through expensive, ineffective paths. Optimize routing preferences for both cost and performance. Azure provides routing controls that let you fine-tune how your traffic moves across the network. By adjusting these preferences, you can strike the right balance between cost savings and application performance. Choosing the right routing strategy can have a major impact on your Azure networking costs. By understanding the pricing models, right-sizing your connections, and optimizing your routing preferences, you can ensure your workloads are both cost-efficient and high-performing. Let's dive deeper into optimizations for what is often one of the more investment-heavy components in your network, ExpressRoute. ExpressRoute connects your on-premises environment to Azure using private connectivity, either direct fiber or a service provider's network, bypassing the public internet. In the Azure well-architected framework, we introduced resiliency tiers for ExpressRoute: standard, high, and maximum. These tiers are based on the peering locations connected to your ExpressRoute gateway, which lives in an Azure region. But the circuit itself resides in a co-location facility, a network hub outside Azure's data centers. Let's look at peering location resiliency. For example, in Atlanta, we have Atlanta, Atlanta 2, and Atlanta Metro. Atlanta and Atlanta 2 are separate buildings, typically within 20 miles, to keep latency low. Metro means Microsoft has ExpressRoute links into both, and we've worked with providers to enable connectivity across them. In Amsterdam, Amsterdam 1 is Equinix AM5, and Amsterdam 2 is Digital Realty AMS8. Choosing Amsterdam Metro gives you a link into both facilities. You'll see this visually in the Azure portal when creating a circuit. Now, when we create the ExpressRoute, we see an option called Maximum Resiliency. This means two standard circuits in two separate peering locations, like Washington, D.C. 1 and D.C. 2. This offers top-tier uptime and latency, even during maintenance, and comes with a 99.95% SLA. To help support this level of resiliency, Microsoft offers a discount on the second circuit. But there's also a more cost-effective option, high resiliency. This uses a single circuit with links into two peering locations like Washington, D.C. Metro. It's a single circuit, but you still get site diversity. The SLA here is 99.9%, and the cost is about 25% lower than maximum resiliency, the same cost as a single, non-site redundant ExpressRoute circuit. Microsoft sees this as a strong balance between mitigating single location failure risks and maintaining cost control. Next, let's dive into networking operational best practices. In this section, we'll explore proven strategies and tools to help you monitor usage, apply policies, and prevent unnecessary costs in your networking environment. You can enable auto-scaling on a few services, including Azure Firewall and ExpressRoute. Azure Firewall scales automatically, avoids per-rule charges, and offers multiple SKUs to best fit your data processing needs. ExpressRoute Scalable Gateway is a virtual network gateway SKU that provides flexible, high-bandwidth connectivity for your Azure virtual networks, helping you efficiently manage network performance and auto-scale resources to meet your workload needs. Additionally, you can optimize the provisioning and data paths with several services. Architect for effective yet cost-efficient hybrid and multi-cloud connectivity. Weigh when to use VPN gateways and express routes based on your bandwidth needs and avoid over-provisioning these services. Remove unused rules from your load balancers and consider which load balancer SKU best fits your workload or environment. Leverage integrated services for efficiency. Azure Front Door includes WAF and DDoS protection, and consolidating applications can help you avoid overscaling. AFD and Application Gateway can both be optimized by disabling unnecessary features and consolidating resources. Optimize outbound connectivity with NAT Gateway. NAT Gateway centralizes outbound access, offering predictable pricing and reducing the need for individual public IPs. Monitor usage and adjust allocation to match your workload needs. Use Azure Virtual Network features for cost savings. Accelerated connections can reduce the need to scale new VMs. By combining right-sized provisioning, centralized outbound management, and optimized connectivity choices, you can achieve durable savings and maximize the efficiency of your networking environment. As an example, let's look at how Azure Networking can help you optimize IoT data ingestion, especially when you're dealing with thousands of devices and massive continuous data streams. Co-locate your IoT hubs and storage resources in the same region to minimize cross-region egress charges. This keeps your data close to where it's generated and processed, reducing both costs and latency. Leverage ExpressRoute for bulk transfer with private, predictable connections for high-volume, secure data flows. It's ideal for moving large data sets from your devices to Azure, offering better reliability and cost control than public internet routes. Use NAT Gateway for scalable outbound connectivity. NAT Gateway efficiently manages outbound connections for thousands of devices, consolidating traffic and offering predictable pricing based on data processing. This helps you avoid the complexity and cost of managing individual public IPs. Accelerate edge analytics with Azure Front Door, which enables real-time dashboards and edge delivery, reducing origin egress and improving reliability for your applications. By caching and processing data at the edge, you can cut network costs and deliver faster insights. Monitor and optimize with Azure Advisor and cost management. Use these tools to track bandwidth anomalies, optimize routing, and identify opportunities to further reduce costs. Azure Networking empowers you to build cost-effective, reliable solutions for high-volume IoT environments. Now that we've covered operational best practices, Let's explore how Azure-wide and networking-specific tools can help you quickly identify waste and achieve rapid savings. With Azure Networking Services, one of the services that can help you control costs and improve operational efficiency is Network Watcher. Enable flow logs to identify high-volume traffic flows and filter logs to detect unnecessary cross-region or external traffic. You can also use Network Watcher together with Azure Monitor to track utilization and adjust resources appropriately. For containerized environments, Retina Container Networking Observability provides deep visibility into microservice traffic, helping you identify costly cross-node traffic and optimize your service mesh or caching strategies. Broader Azure tools are also incredibly helpful. Azure Cost Management allows you to break down costs by service, region, and resource group. Tag resources for filtering and monitor the networking section for trends where you can drill down into top networking cost contributors. Azure Advisor also provides cost recommendations for underutilized networking resources or SKU changes. Advisor can also flag items such as bandwidth anomalies and idle public IPs. Check Advisor's cost tab regularly for optimization opportunities and implement quick wins for reducing your networking spend. You can also achieve governance with Azure Policy and tags. Azure Policy can restrict high-cost resources and enforce cost-efficient network configurations. Use tagging for cost accountability and governance across teams and projects. Finally, you may want to set monthly networking budgets and alerts to detect bill spikes early or alert upon a threshold of expected spend, and prevent overruns or even trigger automation. Forecast future networking costs using historical data and plan your budget and alerts accordingly. By leveraging Azure's built-in tools, you can manage, monitor, and proactively optimize your networking spend to ensure your cloud investments deliver maximum value. Let's recap some of our strategies for networking cost optimization. Analyze costs and set budgets with cost management. Review Azure Advisor recommendations regularly. Architect for locality to minimize egress and cross-region traffic. Optimize routing and choose ExpressRoute for high-volume flows. Right-size outbound connectivity with NAT Gateway. Use NSGs for basic security, reserving advanced appliances for specific needs. Optimize content delivery with Azure Front Door for free intra-cloud transfer and cost-effective hybrid connectivity. Apply Azure Policy and tags for governance. Optimizing Azure networking costs requires a combination of smart architecture, proactive management, and leveraging the right tools. By minimizing unnecessary data transfers, choosing the right services and SKUs for your workloads, and right-sizing those services, organizations can reduce expenses without sacrificing network performance or reliability. Ultimately, optimizing your networking costs go hand in hand with building a sustainable, scalable, innovative network architecture that not just meets your needs, but empowers you to achieve more with the cloud. Thank you.